How are you, my friends? This is Calculus 1 solved questions. Let's do some questions using implicit differentiation, and this is part 2. Please, you can check part 1 for the same idea. Question number 1, use implicit differentiation on the equation cosine of x plus y equals sine of x sine of y to find the derivative dy over dx. So we can directly start the derivative on both sides. So d over dx of the left side here, cosine of x plus y, d over dx of the right side. See, on the right side here, we can see product rule. U times v prime will be u prime v plus v prime u. Here also is easy, the derivative of cosine x plus y, so it will be the minus sine x plus y times the derivative of the inside, which is x plus y as a sum. The derivative of x will be 1, the derivative of y will be y prime, or dy over dx. Now here we have a product, the derivative of the sine of x times sine of y plus the derivative of sine of y times sine of x. You can do that easily. And then we have to rearrange the equation. So we multiply minus sine x plus y times 1, we leave it here. And then cosine of x times sine of y, bring it on this side, on the other side, becomes minus. Now, when you multiply this with dy over dx, that's a minus sine x plus y. Take it on the other side, becomes plus. Plus cosine of y, dy over dx times sine of y. Take dy over dx as a common factor. And then divide by this coefficient. So what do we need here? dy over dx will be minus sine x plus y minus cosine of x times sine of y divided by this sine x plus y plus cosine y sine of x. Please try it again on your leisure time. Question number 2, find the slope of the tangent line to the curve x squared plus y squared plus tan of xy equals 1 plus sine y minus 1 at the point 0, 1. Also, we have to find the slope, which is dy over dx or y prime. So let's find the derivative on both sides using implicit differentiation and chain rule. So the derivative of x squared will be 2x, the derivative of y squared 2y y prime. Tan of xy will be secant squared of xy times the derivative of the inside as a product. 1 times y plus x times y prime, that's a product rule, is equal to 0. The derivative of the 1 plus cosine of y minus 1 times y prime, the derivative of the inside. Now replace x by 0, y by 1 at the given point. So every x you put 0, every y you put 1, then you can find y prime. So this is 0, 2 times 1 times y prime. Secant squared of 0, secant of 0 is 1. Xy, that's 0, 1 times y is 1, x times y prime is 0, that's 0 cosine of 0 times y prime. So when you solve everything for y prime, you get 2y prime plus 1 is equal to y prime. Take y prime on the other side, so derivative will be minus 1, which is the slope, minus 1 at the point 0, 1. Question number 3 may be a little harder. X to the power y equals e exponential to the power x minus y. Let's find dy over dx. We can use here, for the solution of question number 3, we can use logarithmic differentiation and implicit. So we can take ln of both sides to make the function easy. Ln of x to the power y is equal to ln of e to the power x minus y. Just directly take here ln on both sides. Use the properties of logarithms. So this becomes y times ln of x equals x minus y. Now we find the derivative of this simple equation. So the derivative of y times ln of x will be the product rule. You know now the product rule. So it will be y prime ln of x plus y times 1 over x, the derivative of ln of x. On the other side, the derivative of x will be 1 the derivative of y will be y prime. Now rearrange the equation. X, you multiply by x here to remove all these fractions. So x times y prime times ln of x plus y is equal x minus xy prime. Bring all the terms with y prime on one side and all the terms, the other terms on the other side. Take y prime as a common factor, and y prime will be exactly dy over dx. So it will be x minus y divided by x. In the bracket, you can write 1 plus ln of x. Question number 4. Find the slope of the tangent line to the graph of this equation. Y square root of x minus x square root of y is equal to 12 at the point 9, 16. So x is 9, y is 16. Now first, we have to find the derivative on both sides using implicit differentiation. And there is a product rule also, and there is a chain rule. So now we know this story. The derivative of 12 is easy, so we can write here 0 on the right side. Now the derivative of y square root of x, that's a product. And also x square root of y is another product. So it will be y prime square root of x plus 1 over 2 square root of x, the derivative of square root of x times the y. Here we have to put a bracket before the minus. The derivative of x will be 1 square root of y. The derivative of square root of y will be 1 over 2 square root of y times y prime, because y is a function of x, times the x. Now replace x is equal to 9, y is equal to 16 in this last equation in the derivative, and leave y prime. Please, you can go through the numbers here. It's not that difficult, some fractions, until you reach 15. Y prime over 8 is equal 8 over 6. 8 over 6 we can divide by 2, so it becomes 4 over 3. Now we multiply by 8, divide by 15. The slope, which is y prime at this point, 9, 16, is 32 over 45. Please check it when you study. Question number 5, we need the equation here, not only the slope. Find the equation of the tangent line to the curve given implicitly by square root of x plus y equals y squared at the point 0, 1. So here we have a graph, and we need the tangent line at this point 0, 1. X is 0, y is 1. So first we have to find the derivative using implicit differentiation. So the derivative of square root of x plus y equals the derivative of y squared. So you just take the equation there and find the derivative. Derivative of square root of x plus y will be 1 plus y prime divided by 2 square root of x plus y, and the derivative of y squared will be 2y y prime. Replace x by 0, y by 1 in the last equation to get the slope. So 1 plus y prime, 2 over 2 times in the square root is 0 plus 1, 2 times 1 times y prime. So y prime will be 1/3. Now remember the equation from the algebra, y minus y1 is equal m x minus x1. y1 here is 1, and x1 is 0, and the slope is 1/3. So when you rearrange the equation of the tangent line, it's a straight line, so it will be 3y minus x is equal to 3. That is the equation of the tangent line. Now, question number 6 is a nice question. Find the number of points on the graph of this x squared plus 3xy plus 9y squared is equal to 3, where the tangent line is horizontal. So this is a graph here. We have to find the number of points. How many points? Maybe 1 point, 2 points, 3 points where the tangent line is horizontal. So what do we have to do? Take the given, find the derivative on both sides using implicit differentiation and chain rule. So it will be 2x plus 3 times 1 y times y. There's a product here, see, u prime v plus v prime u, plus 3xy prime plus the derivative here is 18y prime, and the derivative of 3 will be 0. So from here we can find y prime. Just take y prime common factor, move 2x on the other side, move 3y on the other side. So y prime becomes minus 2x minus 3y divided by 3x plus 18y. Now, horizontal tangent, when y prime is equal to 0. So I put y prime is equal to 0. That means the numerator is equal to 0. Solve for y equals minus 2x over 3. Then I replace this y in the original equation here. So we have here the first y, see this one here, 3xy, so I put minus 2x over 3, and I have 9y squared, I put minus 2x over 3 squared. Simplify the whole equation, remove the fractions, multiply by the LCD, you will get x squared minus 2x squared plus 4x squared is equal to 3. Simplify more, x squared will be 1. So x will be plus or minus 1. So at 1, we have a horizontal tangent. At minus 1, we have another horizontal tangent. So the answer for the question will be 2 points, because the question said, how many points where the tangent line is horizontal? 2 points. Now, for more questions on implicit differentiation, you can see lecture number 13 in the Calculus 1 lectures. And always, you can go to Calculus 1 solved questions for more questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.